If I tell you that these are some of the values of a sequence and then I ask you a question, can you tell me what is the next value of the sequence? I'm absolutely sure that you will be able to say that it is 16. In the same way, if I show you another sequence and I ask you the same question, can you tell me what is the next value of the sequence? You understand that the next value of this sequence is obtained by summing the previous two values. So the next value will be 21. Let us look into another example. This time, let's say you have a series like this one. This may look a bit complex, but if you put a little effort into it, you will be able to figure out that the next value is 39. This series shows a regular pattern like this one. An important thing to understand here is that one of the major reasons why you're able to figure out the next values of all the sequences is because these sequences are correlated to itself. Which means if we consider this part of the series and this part and calculate the correlation between them, we find that they are almost perfectly correlated. In the same way, now if we consider this part of the series and this part and again calculate the correlation between them, then again we find that they are almost perfectly correlated. Now, if you observe such a sequence over different time points in equal intervals, then what you have is a time series data. So, if you have a time series like this one and you are asked to forecast the value on the next time point, you know what to do. The forecasted value would be 21. Again, you're able to do it because the series is correlated to itself at different terms. We call such correlations as the autocorrelation. However, in real life, we never see such perfect autocorrelations. But still, we can use this concept to make wonderful forecasting for many time series data. Although all this sounds beautiful, but forecasting based on such concepts was not very popular until in 1970s when a book on time series was released by the famous Box and Jenkins. Prior to that, we were using different kinds of models and some of which are even popular today. Now, let me welcome to my channel and to this lecture series on forecasting, which I have designed for all those who have some knowledge on statistics and some basic knowledge on R programming. In the first part of this lecture series, we will discuss some of the very interesting models that we were using before the concept of autocorrelation was used for forecasting. In the next part, we will discuss several models which uses this concept of autocorrelation. This is going to be fun, so keep watching.